Okay, so now we are going to find the initial rate of our reaction. So we're going to look at page 49, see page 49, and we can determine our initial rate. So our initial rate is the disappearance of the peroxydisulfate. So the negative change of our peroxydisulfate over the change in time. But for us, this is actually hard to measure, so because we are actually looking at how fast the iodide starch complex is being formed. So we actually use how fast the thiosulfate is consumed, which is 1/2 times the concentration of thiosulfate divided by the change in time. The reason that we can use this is because we know exactly how much thiosulfate we put into our reaction, and then the iodide complex shows up with the starch. Okay? So that's why we use this one instead of the disappearance of this guy. Okay, so now we're going to bring everything together, and based on our initial rate calculation and the orders of reaction, we're going to find our K value. Okay? So we are going to find the rate constant. So we are going to use, 5, we're going to bring everything together. Okay, so we're going to solve for our rate constant. Oops, thinking ahead. Our rate constant, which is our little k. All right, so we know that our rate is initial rate equals our little k, which is our rate constant, times the concentration of our iodide, and we now know that our order should be 1. So you guys don't have to put this if you don't want to, but our rate of reaction order is that, times our peroxydisulfate, and our rate of reaction is 1 here as well. Again, you guys don't have to put the 1s because it's known that it's 1 if you don't put anything, okay? So to figure out what our rate constant K is going to be, we're going to divide each side by the concentrations. So we get little k equals our initial rate divided by our 2 concentrations. Okay? And then you will calculate the K's for each reaction and each trial. And then you will have, reaction 1 and 4, trial 1, 1 and 4, trial 2, 2 and 5, trial 1, 2 and 5, trial 2, 3 and 6, trial 1, 3 and 6, trial 2. Okay, so you should have a K for each one of them. So the next part is task 3, where you do the exact same thing as 4 and 5, but you're going to have different times now because it's temperature dependent. So you guys measured the rate of reaction, so you measured in seconds how long each reaction takes how long the reaction 1 and 4 takes at 4 different temperatures. So this is going to be 6. So finding K of reaction 1 and 4 at 10 degrees room temperature, 30 degrees, and 40 degrees Celsius. So you will now calculate the K constant for reactions 1 and 4, and these are going to be different, right, because our time is different. So that's how it's going to change. Okay. The last part, number 7, is converting Celsius to Kelvin. You guys should already all know that, so you can do that on your own. And then 8 is building your graph and doing Linus, which your lab instructor will do with you in class.